Okay, let's get started. Yeah. So I have a battery management circuit board. Just adjusting my screen. So I have this battery management circuit board, which happens to be the Max 17320. And I have a prototyping board that holds this 4S lithium-ion 18650 holder. And it's set up with some jumpers so that you can put in however many cells you need, up to 2S to 4S. And then the IDC connection is your balance leads, your power through the terminal jack. When you first power up the board, the button lets the system turn on. And then it has an I2C connection for monitoring and communication with the IC. Initially, I was trying to do some tests. Hello, Aaron. Initially, I was trying to do some tests, and I was getting garbage data out of it. Now, this is my first time having to make my own I2C library, but I was getting garbage data out of this. So I went and looked at the company's dev board, and they were using a rather fancy UART USB chip that is capable of doing I2C. So I picked up the exact one as a breakout board, and sure enough, the program they've made for Windows is capable of finding it. So my first clue of what was wrong is that it needed to be configured. Once it was configured, it started giving me proper data, at least through the app. I haven't tried it again through a management, MCU board that I've built along with a few other boards for battery prototyping. Annoying thing I've found on this board is you can only save a certain number of configurations, but it doesn't let you change configurations without saving them. So that'd be something you'd have to watch, especially if I get this running fully, which I'll do at a later point. The main thing I want to focus on, so that I know I can implement this into my project, because I know I can configure them, what I need to focus on is just getting the data out of it that I want. So a few things that it has that are really handy is you can tell how long until it's fully charged, how long until it's empty. You can monitor the voltages, and I'll probably use the temperature monitoring, but I don't fully expect anything to go wonky. And obviously I want to monitor how much power is being used. That will help me kind of set up the idle profile, knowing when to turn things off if things are being used, so on and so forth, and kind of gauge how well the barcode scanners will last, which is also where the time to empty is very useful. Now the reason, as much as this program isn't too bad, especially if you want to do an initial configuration, I almost wish companies would spend the time they've probably spent programming this interface and just making a C library. It'd be so much nicer, considering it's an IC designed to go into a product, so more than likely you are hooking it up to something that has an MCU that isn't running Windows. It goes through a whole whack of settings, and there's so many things this has capabilities of doing, and it does graphing. The interesting page is this page here. which gives you the address information and values that are coming out of it. And I'm hoping this is what's going to give me better understanding of setting up the programming. Now, I was getting data back when I was doing the programming, but it was all garbage data. Like, it was telling me each cell was like 5 volts, which obviously they're not. If they are, they're severely overcharged. So I'll be keen to see if this starts responding correctly, because I think I used up one of its saved configs. So this should start up right away. It starts showing me data, and that should be on. Plug that in and plug that in, and it is indeed showing me data. Yeah. Cool. So it is showing me data. Go back to the main page. Because there's like no load, the time to empty changes a lot, but it will jump up to like 108 hours because next to nothing's being drawn out of it. Where is the thermistor? No, there's the thermistor. Let's see if the thermistor jumps up. Yeah. So I only have a singular thermistor hooked up to it, and allows up to 4. Yeah, that jumps up fairly quick. Everything is running normally. If I short out the pins, you'll see it short out. It's pretty effective at monitoring. Yeah, see, 102 hours. So we go to the registers. So that's the value it's reporting back in hex. And D8 is the hex address. Now, it says the address of the IC is 6C. It is not. So this chip has 2 addresses. For whatever reason, it does not actually show up on 6C. It's 0B and 36. Now, the other one I was looking at was temperature, and I'm realizing here it's using the second address for the temperature registers. Can't remember if I was looking at them in my examples. Let's bring over the code I was starting. So let's compare some values here. Most significant bit voltage. So XDA. That is wrong. Oh, here, yeah, battery voltage. Okay, so that one's right. But I think because it wasn't configured before, I was getting bad data back. Cell voltage 1, D8, yeah. Okay. So I have the right addresses. Code 1C. Yeah, okay. So I have the right hex addresses. So, if I go in my main sketch. Oh, wait, the cell number. which is a really interesting parameter to put in place, considering it looks like that parameter is purely set by your configuration. 5B. Let's see, 2B. Is it even? And I purposely, on the cells that are in it, you can see are obviously on the low side. I did that on purpose because I want to have the code ready and actually monitor it while it's charging. And these particular cells are the cells I want to use in the final version. Good for up to 10 amps. Don't expect to be going over 1.5 at most during peak usage. Hopefully far less than that. And the good capacity, they're 3400 milliamp hour. I don't see that as an option. P5. Well, I'm gonna ignore it for now. In the meantime, should be able to read the voltage, print the voltage, read 4 cells, which 2 of them should be proper readings, the other 2 should be 0. Let's read the current. You know what? To see if it's fully working, I want to do current and voltage on a loop. Let's see here. Doing anything interesting tonight, Aaron? Oof, that's unfortunate. always hate headaches, but it's the migraines that that'll really drive you up the wall. Ooh, going to the cinema. I was considering going tomorrow, but I got that meeting. So I'm likely going Friday, because there's 2 movies out that I want to see. And I like doing double features. The only sad part is the movies are spaced out just at the most awkward timing. You miss either one by like 30 minutes. So I'll have a bit of a layover between them. I think the best layover I got was 40 minutes, which isn't bad. I've had worse ones, which is why I built a spreadsheet to help track it all. Yeah, I want to see John Wick and Shazam. Saw the first one, it was good. It's just a shame they can't make up their mind with upper management, which is why most people aren't watching it and are trashing on it. Although it could be a terrible movie, I'll find out. But I mostly just go for the entertainment value. If you build a larger story, sure, as long as it's a good story, but yeah. Well, the first one I thought was pretty darn good. For what it is. Just sucks they made it standalone. Well, in a way, it depends. They keep trying to copy Marvel so much that it obviously doesn't work. Spent time building good movies, you wouldn't have so much of an issue. But instead you want to try and copy someone else's movie model and, well, it clearly isn't working. But hey, definition of insanity is doing the same thing over again, expecting a different result. Sorry, being a little cheeky. Yeah, that should work. Yeah. Actually. Let's put it on different lines. Let's put it on the same line. And this works. It confirms my suspicion that the only way to get viable data was the fact that it was unconfigured. But also means I can use this device in my final testing, which is a bonus. Let's see here. Just want to make sure I have things still set up to read properly. Let's print that out in hex, then I should be able to compare. Here we go. Should probably turn this stuff back on. I have a feeling this one needs some tuning, but Let's try this out. Oh. What? How did I grab the wrong USB cable? Silly me. I'm gonna grab the correct USB cable. Okay. Figure out what port that's connected to. That is port 17. Voltage is wrong on everything. Okay, so we're getting garbage data still. Auto voltage buffer. I think I'm hitting the wrong value back, because that's 2 hex places. That's 2 bytes of data. I think I'm reading 1. Yeah. My request from length. So that should be 2, I think. But let's turn off the loop. I tried to get ahead of myself. And let's try just 1. Turn that off. Let's look at just that. Get the system voltage and voltage of cell 1. Read voltage. actually. Oh, which one am I adding? Reading voltage. Right. Let's turn that off. Turn that off. Let's just focus on voltage for now. And because I believe it's 2 bytes, let's try this. It's a float number. So I had found an example library for this chip, but it was designed for the one-wire interface because this chip supports a few different interfaces. Well, it's a variant. This specific one can only do I2C, but it's something they had in place, and I kind of left it. But I'm realizing here I was only asking for 1 byte of data back, and looking at these, this is 2 bytes of data. So I think that's part of my problem, is that I'm reading the wrong data, or I'm not reading enough data. Let's upload a monitor. B7. I think I'm booting the DA. So X2 decimal. Is it B754? Which gives you 46,932. Let's take the calculator. Wait a second, show this. So 46932 times 0.312 0.32 times 0.3125. Nope. Hello, Keith. Well, that's not right. 54. B7. 21687 divided by what? Sorry, times 0.3125. Almost looks right if you were to consider that the decimal point. 6.7 volts, but it's way too high. Just kind of hoping I'd get that on my readout. Actually, let's see what this gives us. 4E AA. It's 20. And it says it's equal to this. So do I take $21,388 divided by 6.293? $6.293 divided by 20.138. Nope, definitely not that way. Times divided by 6.293 volts. This ridiculous number. So the response was 54B7. 54B7. Definitely higher, which is weird. But 21,687 times, divided by that. It's weird that it's telling me it's 6.7 volts. It absolutely is not 6.7 volts. No way. Yeah, it's 6.29 volts. So this is accurate, but why are we getting such a higher number? Let's try running this again. Well, still giving me the same number. Let's try the other address. The address was 36. Let's see what that gives us. Because one of these addresses is supposed to be for the SM something. B14E is what I got this time. I don't think that's right either. B14E. No, that's way too high of a number. So the other one is right. Hello, Johnny. What is it? Let's see here. Pack configuration. This is the register that I would have needed to get it running in the first place, which is what this Windows program took care of for me. But analog measurement registers, voltage measurements. That's the average of the cells. It's not the one I'm trying to read. Battery register special. Down here. Battery registers contains the total pack voltage measured inside the protector on a 20.48 volt scale with the least significant bit of 0.3125. B7 is my output. But according to this thing, it's getting 4 EAA and then calculating that the voltage is 6.293, which is correct. The only difference of where I'm pointing my ESP32 is I'm pointing it at DA, but I'm pointing it at 0B, not 6C, because 6C does not show up on an I2C scan, but 0B does. That's the only difference. Pardon me. Doesn't help when I'm not getting the right data back in the first place. Is that? Let's see something here. Let's see, I2C read. Byte by read ++. Yeah. Oh, wait, what? Why is I a byte? Weird. But yeah, we start the transmission to the address, we write to the command, stop transmitting, request. Wonder if I'm not supposed to stop the transmission. All the time and effort they put into these data sheets and Windows programs, and they could just spend it doing more useful things for people to actually integrate their projects. Disabling fats. Two-wire bus system. The 6C, I mean? It won't work. Well, I'll have to bypass the startup sequence because it doesn't find anything. Oh, 6D. Okay. Nothing on 6D. Doesn't find it. Only finds it on two addresses, 0B and 36. Wondering if I'm writing wrong. I2C read communication. So this is an example read from the temp address. Which one? 3.5. Average temp. This one here. Yeah, I think I see part of my problem. Sit down in my read, I'm telling it to end transmission. Oh, I think my first problem is how I'm reading. So if you look at their example here, they start it, they write to the address. Is that on 16? Oh, it is. They wait for the acknowledgement and then they start again. But I'm writing end transmission. Which I think is part of my problem. Start is repeated. Oh, Adafruit has an example of this in the library. I wonder if I can find it. Oh. Do I need to rewrite begin then? Let's see here. This just looks like gibberish. Oh my goodness. Trying to read this example to see if I can. It's showing all the high level stuff. And Adafruit's pretty much switched all their libraries to use the bus IO library. Ah, here we go. False. Sets a repeated start. Byte 1, byte 2. That should be okay with this, but let's try setting this like that and see what I get. Nope, get the same value. Okay, let's see what Aaron sent. Have you tried any device example sketches? As if the device has example sketches. Although, granted, in this case, it looks like there might have been example sketches. Read register. Okay. Oh. Doesn't tell you where the heck is he reading the register? Write register. Get dev name. Right. Read register. Okay. Begin transmitting. Fire that right. Right. And false request 2. Well, let's see. Let's give it a try. That address, reading from here, from there, right. No, I was doing the same thing. Okay, let's see how that does. And let's see what that does for us. Oh, there's more messages on Discord. B754. which give us 7. Nope, that's way too large of a number. 54B7? That's what I was getting before. It's the same data. So, getting the exact same data as I was getting with my original loop. That is so weird. Let's go back. This isn't seeing it anymore either. What in the world? Well, not gonna do me any good if this regular program can't read the data either. There we go. Is it doing a reboot? Like, well, that's a useless communication log. If it, right, non-volatile block. Reads or writes a single register location, valid address location. Let's see. Register DA. Read. For EP1. For EP1. Yeah. Okay, let's go back to this. According to them, this is supposed to be working for other addresses. It's just the one item they want to read to, or write and read to. This one here wasn't working. But in my instance, it's doing the same thing. It's still giving me the wrong data. Just this time it's backwards. Sure, I can try and copy over the functions. Actually, I can just put that in the main here. Oh. Oh. Whoa. Yeah, it's saying 58 volts because their value is backwards, but it's still wrong. This part here, it's doing it backwards. Let's increase the delay here. Oh, I know why. I wasn't saving the fact that I had already checked the value. But I'm also gonna reset the BMS board. Let's see what that does. Nope. Still getting a bad value. It's way off. Five 4 B7. It's a right decimal value. Just when you do the math to match this, it's wrong. What's the other address? 36, I think. But even that I2C read from that forum post is producing the same data I was already getting. I could try. Yeah. Wait, oh, this is close. 4EAD, that's backwards. Hold on. If I might have been reading the wrong register, the main address. Hold on. If I switch this back to how it was originally. 4EA8. Let's see here. 4EA8. Oh. 4EA8. What? Four E A 8. That's right. So take that. It's not the calculator. And oh, it's producing the right value. Because 4EA8 is exactly what's coming out of that thing. So I was pointing it at the wrong register. Okay, so that's progress. So let's try this. Let's go back to here. See if this works. Monitor. BB4E. That's wrong. What? E B B. Ah, okay, so this is backwards. BB4E. If I use this, then let's adjust. Let's change this. Void. Let's change it. Oh, okay. pretty much already have that function. So it should get me back to that value, and then voltage. That. Again. Oh. I'm actually curious if this will return the right value. If I let it. False. No, it's getting the hex value. $6291. We now have the correct value. Woohoo! It's in millivolts, but something. Now. I'm just complaining about something. What the heck? Utpeg byte warning says that these are ambiguous even through the worst conversion. Wow. Mm-hmm. Hope this gets rid of this compiler warning. Just in case I need it later, I'm gonna copy this over. Move that. Ah, right. But right now, I'd rather leave it as a non-float. Yeah, it's just easier to deal with it and convert it later. The only time I'd really convert it would be on the server and maybe on the screen. But obviously I can convert it right when I want it to display on the screen. But for general handling, so much easier handling it as a large number. And because I'm debugging, I'd rather have less conversions in place. It's one extra thing to worry about if you're doing it wrong. Okay. That works. Let's see. Let's remove this. Comment it out for now. And oh. Yes, I can do that too. Okay, so let's try this one now. So basically, any of these that say 6C, it looks like the correct address is 36. So when I go to try and read temperature, I have to see if it works on the other address or if it wants the same one. Seven, 5. Okay, let's see if that gives us. And load a monitor. Wait, what? forgot to comment it out. Oh wait, no, it's the second one I want. Yeah. Oh. Ah, thanks, Owen. Well, those are wrong. That didn't print out the whole thing. It's still complaining about down here. These are ambiguous, even though the worst conversion from the first is better than. What? Seems. Oh, so Aaron's pointed out that the I2C addresses seem to be divided by 2. So 6C is 108 divided by 2 equals 54, which is address 36, which is the one that I've gotten correct values from. So the other address is 16, which is 22 divided by 2. That's wrong. Works for that address, Aaron, but not the second one. Because the other one is 16. But what I just tried was to get these ones, and it didn't report back properly. Let's remove this, divided by 1,000. For a moment. So those values are all wrong. That value is correct. What in the world is going on? Oh my gosh. What in the world? Oh, wait. D8. That's absolutely not what I'm sending. Oh, okay. These are wrong. 7, 8. Would help if I'm sending the right values. What? I could have swore I got those values from a piece of documentation, but according to this, they're wrong. Okay. So this should be D8. D7. D6. D5. Upload a monitor. Oh, that compiler warning is driving me nuts. Why is this ambiguous? Can I do this? 0x02 and not have it do that? Hey, we got the correct values now. What do you know? F00? Ah. Not bad. Now, does it have a value to tell you the difference between them? I don't think it does. But the other one I need is the current. Oh, and the other ones I need are these ones. Yeah. Okay, that's working. Yeah, so I'm gonna need temp 1, which is on that other address, so I'm expecting I'm gonna have to change it. But the other one I know I need is current. And I had already started to write a thing for current. So, okay, let's clean all this up. At this rate, I'm gonna have a working project. I was originally going to live stream this stuff yesterday, but Looks like I'm having a meeting tomorrow, so I put a few extra demos together just so that I could physically show something that I'm working on. Not that the people I'm doing work for don't understand what I'm doing, it's that having something physical, I find more people can understand and relate to it rather than me speaking tech continuously. So our sense is, so I need to know what the sense resistor is. That would help. Configuration. So one of these I think. Nope. I really dislike that we're designing this kind of crap into things. This is, you can put an encryption on it. So if you're designing a product in your own series of batteries, essentially you could lock the thing down so that only your batteries work with the thing. I think that is garbage. It knows the sense resistor. Oh, and the other update I can give is, so I'm trying to get RFID readers for the tags that the staff use. And the company I've been in contact with for 7 months now. Finally got a response today. The other week, finally narrowed down the product code for the reader that I want. And I've been looking at the OEM options because it's the bare board. So it'll be easier to work with. It's smaller, it's more compact, and it gives me more programming options than the standard stuff. It's also quite significantly cheaper. It goes from being $235 a reader to $125 a reader. What was annoying is half of my emails weren't being properly read, so I'm going back and forth for no reason. And then trying to talk to the distributor because they keep forwarding me to the distributor, and then I'm talking to the distributor, and the distributor doesn't have the information, so they're playing email chain with the main manufacturer, and it's just like... Eventually, had a phone call and realized the distributor does not normally deal with the OEM model that I'm looking for. So then I bypassed the email chain and talked directly to the manufacturer, and finally the person didn't forward me back. Narrowed things down quickly, and then they go to set up the account and get everything set up so that I can order. And what also didn't help is the initial pamphlet I was given like 7 months ago that had some product information, had partial product numbers. And typically, depending on what you want, it fills in part of the equation, but it doesn't give me the information to fill it in, so I have to contact someone to fill it in for me. Found out those model numbers are no longer relevant, so why it's still on your website is beyond me. But the new one that's supposed to replace it isn't available until late Q3 this year. Thankfully they're offering to put together a sample, so at least I can get one scanner working, tested, programmed, have the other ones ready to go, so that all I'd have to do is put a reader in them. At least I'm hoping that's how it works out. Hopefully it doesn't take too long to get a sample. And the good news is I have 3D files that should very closely match it, so I can at least design the scanners once I have the battery boards and the MCU board designed. I'll be able to design the scanners for 3D printing, and just in time I finished building my 3D printer cabinet. The only real plan B would to do some sort of pin code, but then that gets super tedious trying to manage all the different staff's pin codes. And the other option, I was joking with someone online today, was at this rate it probably would have been cheaper and easier for me to buy the Flipper Zero and engineer the protocol and build my own scanners. 7 months. Like, and the Office already uses these exact same readers, but the non-OEM version. Yeah, well, so I'm already putting in these. These are the PN532 readers. So they are GProx 2 codes, which I think is a sub-HID code thing. And I don't know what's so unique about them, but I bought a cheap $30, $40 China HID RFID reader, and it couldn't get anything from it. Yeah, it's got an interesting protocol, but from what I've seen online, apparently the Flipper Zero might be able to get data from it. I'd have no idea without actually testing it. But it's also $400 for a Flipper Zero. Yeah. But I had thought, like, what if we just slap a 13.5 megahertz like sticker code on it? But again, it's on a code, it's easy, especially the sticker ones, it'd be very easy for them to wear out. And if you gotta dispatch the plastic tags, like the key fob style ones, you could give staff these, but again, that's something extra to manage. I wanted to try and use existing hardware if I could. They already have those staff tags and everything is set up for that, so why not try and make my system compatible with what they're already using. So if it goes to other organizations, from what I understand, the readers I'm buying are supposed to be capable of 13.56 megahertz. I'm not sure if it automatically allows that. More than 10, less than 100. So if it went to an organization, obviously I'll test it when it gets here, but if it comes from an organization that doesn't already have them, yeah, I know, right? There's so many things that'd be like a million times faster. I could always switch to those 13.56 readers. Because I'd already have a reader compatible with those tags, although I would hope the other one's compatible, to be honest. Just makes programming a little easier, but I know there's at least one agency interested, and I'm supposed to go have a meeting / tour of the facility. And that would actually give me a chance to kind of see how they do things. Because I already volunteer with the person I'm building this one for, I kind of know the process and I know how to improve it and automate things, which is what I'm initially setting things up for. But I want to try and make some of the code I build to be dynamic, but also at the same time I know that the whole premise is very unique, which is why we're not using something off the shelf. I've already been asked that once. Well, can't we just use an off-the-shelf inventory system? No, you can't. It's not designed for it. Not even close. CF. Apparently, sense is a singular thing. So, can I instead change this? So let's try. Wait. Why would I want it 16T if I'm only reading the one? It's very weird. Also, just realized if I'm gonna try and see what it responds with. Stop from finding that and disable that. Let's print out that buffer. Actually, the reading of it already prints it out. Come over here and tell it to read that. That should tell me what the sensors. I should expect it to be 500 if I'm not mistaken. Yep. I've always thought phones would make a good option for replacing RFID systems in a building, to be honest. Staff almost always have their thing on them. Now granted, they have to keep a photo ID as well that's branded, and typically they have the RFID and the branded thing on the same lanyard, but yeah, it's a very old tag that they use. It's basically security through obscurity at this point, but it's also government run, so them getting any sort of change to update it would be almost not going to happen. And the main bulk of the tag is run through their security company. So, although, now that I think about it, if I'm not mistaken, their lease is up next year. And they're likely moving in January. There's no guarantee they take the system with them. I'm gonna have to follow up on that one. It'd suck if I go through all this effort to integrate that tag and then it gets updated to a more modern tag for a new building security system. Also, those tags are very expensive. Apparently a box of 25 costs them like $400 or $500. Thankfully I found an old box on eBay for like 60. Yeah. Oh yeah. Oh, there's my notepad. I have notes in here. This is my project-specific notepad. Now, ideally, another option is because they have the photo ID codes that are printed on the PVC code. You could always design a QR code onto those tags and use that as an option, but obviously you'd have to reprint everyone's tag. And the other problem with that is I know some staff, the problem with the sticker would be it wearing out too fast. Unless you used vinyl stickers. That's the problem even with their current staff ID tags, is it fades. And it fades somewhat quickly. Especially when you got two tags rubbing up against each other. Oh. Oh no, that worked. Okay, upload monitor. Either way, I'll have all the hardware I need inside of the scanners to change options if I need to. Still complaining about that? Like, really? That's so annoying. Ah, here we go. FF58. Oh, I know. because I only wanted the value out of it. So oh no. Oh, Keith, that would suck. F58. So that's backwards. So wouldn't be at so 58 was 88. What? Well, that's not right. That's the problem. It's not not showing up in this list. From what I understand, it's only supposed to be a single byte of data. Although I guess I could be wrong on that. Let's try reading 2 bytes of data. Because it should give me the O-sense value. This one? It just tries to read data. It doesn't really give you much. It's useless. Doesn't really, other than telling you that it is or isn't capable of communicating. E158. E158. Oh, let's try that again. E158. I know that's not the right value. Let's go over to the documentation. .58 E1. That's still way too large of a value. Because the way this was set up originally was it was just reading 1 byte of data, so the 58 would be what you'd want to read, which is 88, which does not match any of these values. So it would be returning this, which isn't right, because it's 5 milliohms, so I would expect it to be 500, to be honest. Temperature protections, analog measurements, current measurements, sense 1CF. Sense register. Default factory value. 01 F4. Yeah, 500. So that's what I should be getting back. min-max current. Register type special. Let's see. Do they give a could fake it, considering I know that I'm using a 500 milliohm. Correct one is 1C. I knew it wasn't going to like that. Oh, it allowed it. Yeah. Wonder if this is on the other address. 0B. And let's just print out the current reading. Should be pretty much near 0. Well, that's not right. Ah, here we go. 1F4. Default value should be 1F4. Where was it? It's over here. Haha, 1F4. Haha. 1F4. Oh, no, clear. 1F4 is 500. Hee hee. So that works. So we can turn all of this back on. Okay, so we know that's working. FFE. I feel like that's backwards. Oh, I wonder. Oh, it's 6C. But it should be 0, 0. Anyway. Oh, in hex, sorry. E. 14. Ah, okay, yeah. I think it should be 0, 0, not FF. What happens if I change that to 0, 0? Nope, doesn't like that. FF5 1C. Yeah, trying to point it at 1C. Let's try this one. X00. Okay, so that's a start. Would have expected something. Not much, but something. If I run this. that. Whoa. Oh, I know why. Okay. Yep, ground. I got this board with these ridiculous sized LEDs for testing. These are 10mm, and then this is a 20mm LED. I saw it on Mouser's inventory, and I thought, oh, those would be neat to take a look at. Nope. That voltage seems a little high. 6.2? Indeed. .2 volts. That seems a little high. No, it's 6.29. Okay, that's right. Just not getting the right current value. He is 14. What math is it using? So we go back to using the correct address. The only issue was that it was reporting FFF something. And I think all those F's are supposed to be 0. I think. Unless it's in milliamps. So what is 14? So it was reporting E. It's 14. 14. Divided by 100. Yeah, 4.375 milliamps. Okay, so it's right, but it's wrong. How the heck do I change it from being FFFE to being 000E? Because it's basically reporting this, but instead of 0, it's setting F. But it's not a string, Aaron. It's a hex digit. It's a UINT 16T. padding leading zeros. Ugh. Could add larger math to it. It's reporting. Yeah. Ooh, that's a good one. Yeah, that's what it reports. But those F's are supposed to be zeros. Oh. Is that a negative number? Yeah, see, when it goes F, it's supposed to be negative, I imagine. Oh. Gosh. And I think the easiest way to prove that is if I put a load on it to force it to stay positive, it'll switch. Upload monitor. So FFE would be negative 4 point something milliamps. Huh. Yeah. So it's FFF9, and now it's positive. Yeah. So when it's showing the F, it's going negative. See, negative. So, yeah. So that's me pulling power out. But if I put power in to charge, it'll go the other way. So it needs a whole bunch of math to fix that. Let me go find a charger to test this. Okay. Okay, plugged in a charger. And it should drop. Instead of being F, it should be the other way around. Yeah. Oh. Getting a bad connection. Hold on. Let's... So now it's charging. You can see how the number changed. Goes from being the F to the other way. So this would be negative or positive? I have no idea. But one shows power going into the batteries, the other shows power coming out of the batteries. So that'll be a fun one to find the math for. Well, I'd say for now it's a success. So let's add the temperature reading. Let's change this. Temp. Yeah. Temp. One B, I think. Oh no, 3.4 is die temp. 1B. Is 1B just temp 1? Or does it average all the three of them? Actually, you know what? I am better off using this because I'm imagining that it's that second address. And I'd rather just leave it alone. Retemp 1B. No, that's D. 0x 1B. And the other one is 3.4. 0x 3.4. Oh, 3.4. I'm gonna turn this off. Don't need to read that. I have to sneeze, but it's just hanging on. Oh jeez. All of these I'm going to replace with defines later. But, read die temp. Let's figure out what the math is for it. And then once I have temp, the only two I need after that are these two down here. Which are the time till charged and then time till discharge. This will be very helpful during testing. Hoping at least 8-hour runtime, over 7 hours preferably. But ideally, see you later, Keith. Thanks for hanging out again. Die temp register. 1B and highest thermistor temperature if enabled, or the die temperature if the thermistors are disabled. Okay. So it's a direct value? What was it showing here? Clear. Showing 175C. Which is 5,980. So it's clearly a converted value. Oh. C resolution. Ah, here we go. For temperature, I haven't shown it yet, but the math I need is this right here. Actually, if I want the die temp. I'll add comments to things later. I normally do, especially for libraries, so that you can hover over them and see what it's supposed to do. Let's see what that gives us. So that's giving us 19d6. Which matches that. So now it's a matter of knowing what the math conversion between the hex and value is, which I believe is this. So the high byte is in Celsius. Oh. I did it in, what is it? Did it in the printer library. File, new window, open recent. Did it in, no, it's in here. Actually, no, it's in the CPP file. Here it is. Yes. That's right. Let's see here. $66 divided by 128. No, wrong about that. Let's see. Wonder if I'm lucky and the math is in the repo I found. Looks like someone new made a new library for it. Oh, they haven't added much to it yet. That could be right. be pretty darn close there, Aaron. I think it's right. I think I just have to divide it by 256. H. Oh. Wonder if this is capable of doing a cut. Doesn't seem like it's set up to show the positive or negative. That's unfortunate. Yep, divided by 256. Oh, look at you being on top of the reading there. I'm getting sidetracked. Oh no. Hold on a minute. Divided by 256. I want to times that by 100, don't I? Because that's going to give me to the decimal point. No, it's already in Celsius with the 256. I am in Celsius. Love my Celsius. Thank you very much. Times 100. The only one I can't get used to is doing housing measurements in millimeters or centimeters. And then the new one that realtors have been trying to switch to is doing meters squared for footprint. I'm way too used to cubic feet, and I can't do it. I'm way too used to doing construction in imperial units, especially because most of our material comes in imperial units here for anything industrial or lumber based. The only time I tend to deal with millimeters is machining. Granted, in machining you'll switch between both depending on the project, and 3D printing. Thankfully, math and shop stuff was always my strong suit in schools, so I never had issues kind of converting and dealing with fractional stuff, but yeah. Some driver coming up from the States the other day made the mistake of thinking our road signs were in miles an hour. It was not miles an hour, it's kilometers an hour. Actually, I could have swore our road signs normally say kilometers. But I could be wrong, it could just be the number. Or at least the ones by the border, you would kind of expect them to write the speed. Yeah, see, the most common road sign we have would have the kilometers an hour written under it. It's not very often you see it written like that with nothing under it. Yeah. Yep, our stunt driving rules changed during the pandemic. So on a road that's 80 kilometers an hour or less, going 40 kilometers over the speed limit is automatic stunt driving, which is a 3-day impound on first offense. Second offense turns into 7 days, and then third offense turns into 30 days. And you still have to go to court, and they can increase that by whatever. And the fine is something ridiculous too. And obviously you have all the impound and tow fees on top of that. Yeah. So, for a road that's 80 kilometers and over, it changes to 50 kilometers is the threshold. But yeah, they're pulling people over doing double the speed limit. It's absolutely nuts that people think they can do that. It's bad enough when the motorcyclists do it, but doing it in your massive SUV sedan, oh, it's a disaster waiting to happen. So this should work. If I tell it to print, should get the correct values. $23 and $25. 19cc. Our highest speed limit is 110 kilometers an hour, and it's on very few stretches of highway. Now, granted, the normal speed that people tend to drive in those zones averages 120 to 130 easily. Hex. That was 19cc, which is 6604. Divided by 256. So that math went wrong. It's saying 25, but it should have. So it's saying 25. That's not what it should be. Actually, 256. Oh. If I do 256. It was 19cc. X604 times 256? No. it should be, sorry, 6604. Now, granted, if I set it up to be a float, it would send the correct value. I'd have to go look at how the temp libraries do it. Divided by 256. So this number, it says 2500 right here. It should be saying 2579, but it's not. The one above it is, oh no, that's the voltage. And the one below it is wrong too. It's saying 2300. 6604 times 1.256. No. Just to check. I think it's a syntax issue. Let's try that. Yeah, no, that's not working. Yeah, that's what it should report back. Still showing 0, 0. Die. Temp equals divided by 56. Oh, it's not saving this as a float. Yeah, I see it. I have to learn an experiment. Because I'm trying to cut the variable count down so that it uses less space. Actually, I can do it this way. Times 2.56. No. Divided by 2.56. So 6604 divided by 2.56. Haha, there we go. That's what I wanted. Divided by 2.56 F. Haha, 25.77 degrees. And the external temp is reading 23.79. Hehe. Good. Progress. And that leaves these as my last two items. Read time to empty. Time to full. No, like, just in terms of space that it uses as a variable, you'll use less space keeping it as an int than trying to keep it, well, int goes both ways, but it's an unsigned integer 16, so it's only positive values. But it will use less memory. And the only time I need decimal places will be on the server side, which I can easily divide it by 100, or on the LCD screen, and again, right when I go to print it, I can just divide it by 100. I might change it later, but at least for now it's working enough that I can do what I need with it. The whole point of this programming is to actually get something that works, so that I can move to the next step, which is designing circuit boards. And the register is... time to empty is 11. And time to full is 20. What is... Let's see if this... I don't think this person put it in the library. No, they didn't. Ooh, read capacity. That might be a good one. I don't think that one calibrates until I charge it. Read capacity. So X6 06. Ah, this one. Reported state of charge. That might also be half worth adding. Can show it as a battery percentage rather than always having to calculate how much power is being used and constantly monitoring current. That'll be a good one to add. And then the only other thing to fix is the current reading. You have to be able to read positive and negative values properly. Well, I don't fully understand how that works. Because presumably you'd always have to have the you'd always have to have the leading bit be F or 0. So max you could do would be FEEE. Oh no, sorry. FEEE. So that'd be the highest you could go in any one direction. Wait. Unless it adds more bytes to it if it got higher. But I don't think it does. Yeah. Interesting. El Supremo. Oh. Ah. Nice. I was thinking of making, even when I do figure it out, well, this is good for printing out the value. I'm gonna probably make another variable that tells you if it's positive or negative. Not sure if I'll actually need it, but I'll make it. It's actually the added bonus to making these videos is it kind of gives me a log of doing stuff, so if I really need to, I get to spend, at least for this video, 3+ hours just watching myself over again as documentation. But this is very helpful. Right. Then need to check. That's the one I want to read. These are the ones I'm looking at right now. Wait, what does that say? 20. Oh yeah, okay, I recorded that right. Oh my goodness. Oh, that's how it calculates it. Under present current temperature and load conditions, has a maximum value of 102.3 hours. Oh, that's nice. They give you the data you need to actually calculate it. Doesn't give me the math though for converting the value, but it does. Right, no. Actually, it partially does, because it's 102.3. It's the maximum it can show you. Cool. I'll keep that in mind, Aaron. Aaron gave me the answer to storing a value with whether or not the current is positive or negative. So if I do 65535 divided by no 64061 Okay. That'll work. But that doesn't give you the time for fall. Oh. Maybe? Yes. Yes, it would be. I'm probably going to keep it in hours, though. I'm just not displaying it in the decimal, which is why I was adjusting the multiplication. But what would be... Oh, right. I see what you mean. Well, that's gonna be huge. I'm gonna leave it like this for now. But it's the time to empty that I'm gonna need to see. That's what the data sheet says here. Time to fall. No, it should be the same for the time to empty. Let's come over to here. And then that gives you hours, not hour. Yeah, hours. Just the last digit is times 10 for the decimal point. So the maximum is 102.3 hours. Yeah, so right now time till full is maxed out because you're not actually charging it. Time to empty is maxed out because you're not pulling any power. If I start pulling power, should see a value change. Although I don't think this is a large enough load. No, you have to convert it to the 102.3 first, which is the 60. So if I wanted it to be the 102 hours .3 that it's maxed allowed to be, I would move this 0, so the value back from the register divided by 60.61 gives you the 103 or 102 hours .3, but I didn't want the decimal point, so I moved the 0 over to the other side. I don't think this is pulling enough power to change the time to empty register. Unless I'm thinking of the registers backwards, and the time to empty is actually the time to full. Let's see here. I still have the charger here. Plug it in and see what changes. Granted, I could plug it into the MCU. Oh, that failed. Okay, that's charging. Let's see what changes here. Haha, time to full, 31 minutes. Well, 31 hours? Or is it 2.6 hours? Yeah, 2.6 hours. And time to empty now has switched. Because we're charging. Okay, yeah. So the reason it was showing time to empty to 0 was because there wasn't enough load on it. So if I put enough load... I'm trying to get everything working first. We can go through data sets later. It is working, I'm telling you. That's 2.5 hours. Okay. Yeah. Time to empty, 159. But the load is dropping off it, so. And this LED board, I think I set it to some really low level. It's not going to pull a lot of current. Although it is still trying to tell me the empty. Every once in a while the current is spiking enough that I can read it. So this is 1.5 hours. So that'd be 1 hour. 0. Was it the other way around? Would it consider it maximum time to empty when it's at 0? Ah. I'll fix the decimal place before I do full testing when it's in the scanner. But the other one that is going to be useful is the reported SOC, which is what it's going to use for the time to empty calculation as well. Oh, you're not entirely wrong. It's just I want to make sure that things are working properly first before I start trying to do all the math on everything. I'm at 0.6. No. No, the scanner is going to be designed to be together. So you just put it on the charger. I'm not designing removable battery trays into it. But obviously, if the batteries degrade too much, then yeah, I can just swap new batteries into it because I'm going to be using the trays. The test board. So the purpose of this test board is that you can test anywhere from 1 to 4S, 2 to 4S batteries, and then I have this MCU board that has a spot for a TFT, and then there's a charger board and there's a power delivery board. The power delivery board has some interesting quirks, so it needs a redesign. But for the scanners, I don't plan on using that power delivery board. Just wanted a whole suite of items. And then the other board I'll be using is this battery charger board. And the unique thing with the battery charger board is it can monitor power going to your battery, but also your load. Which is kind of nice. And so those are the two that I need working. I need this BMS and I need the charger board to work so that I can design it into the scanner. And I'll be doing it with a 2S holder. So the one side of the circuit board will hold the holder, which I can do with my soldering iron really quickly, and then the other side will be the surface mount parts that it needs. And then the only connections you need are the I2C connection and the power connection. So if that fails, I can pull it out and put a new one in. Right. And the math for the state of charge. Percentage. The other one that could be done is reported capacity, but I prefer the percentage, to be honest. Really? Doesn't give you the math for it? Seriously? Like, it's... Unless it's simply percentage. Which the only way I would know is once I actually start charging it, it should go up to a maximum of 100. So it should top out at 6.4. Yep, we can do that too. I'd expect it to just output 0 right now. The batteries are pretty much dead. But I'm doing that on purpose. Because I want to be able to test it charging and seeing all the values output. What I might do is actually hook it up to Node-RED and... oh, what's that one thing called? InfluxDB, I think it is. And have it graph it for the 3 hours or whatever it takes to charge. Have it track all the values for me. Especially these values would be nice. Mm-hmm. State of charge is 353. What? That is not what I expected to see. I expected that to be 0. Well, let's connect it to this and see if it corroborates that. Yep, it does indeed. 1.4%. Oh, don't need that anymore. Oh, would help if I actually connect the board doing it. .33%. Cool. I'd say that's a success. Don't need that on still. Other than wanting to convert all these hex to fines, it works. So I don't think there's anything else that I want in terms of functionality. Like, it'd be nice if the library can configure it, but I can worry about that later because I can configure it through the app. Yes. No, I'll do that when I fix all the float values. Right now it's just a I need to get the devices working kind of stream. So I'll pretty much leave this as is unless there was other functions I wanted, which right now it does not appear that I want to change anything else. Current measurements. I think it's supposed to tell you the age of the battery pack. Calculate a percentage of the application's percentage cell capacity compared to its expected capacity. Allows you to gauge the overall health of it. But you'd have to run a few cycles through it before that starts to become accurate. This one wouldn't be a bad one to integrate. The number of times it's been on the charger. Although granted, everything's on gonna be on MQTT. I could calculate the cycles on the server, to be honest. And if I'm really checking the cycle count, I could just plug in a secondary. I could either add extra code as a test or plug in a new I2C cable and check it. Really don't have much of a need to constantly check the cells. Cool. The other IC is... I'm not going to do the other IC tonight because I need to go to bed at a reasonable time frame. Although yes. Yep, the server's going to have quite a bit packed onto it. It's an overkill server, but I wasn't entirely sure how everything would turn out with what I'm building, so I spec'd hardware that is cost effective for what you're getting, but can more than meet the needs, and then it'll give me a chance to see how everything performs, and then if I spec other systems, I can potentially choose something that's more cost effective if needed. Although, in all honesty, using it in a professional environment, you're probably better off spending the $3,000 to have a good piece of equipment that isn't going to fail on you. So, but that's my opinion. Still waiting to hear back from the IT department if I'm going to be good to go on ordering stuff. The big question is, can I set up my own Wi-Fi network, or am I going to have to use those NRF radios? Please be Wi-Fi. Right. Charger. This is the charger. Oh, that's the FET that's on the charger. Really nice FET, I gotta tell you. Probably gonna use this for a few things. These suckers are small but very capable. Like look at 110 amps at 40 volts. That is bonkers. Now granted, that's at 170C. That is going to be hot. You better be running a heatsink on that sucker. But even still, the size of it, that is nuts. But considering my project is space limited, it matters. This is the cool thing, is this battery charger is a buck boost, which is kind of nice. I think it's absolutely ridiculous that it does up to 16 amps. Yeah, a lot of these parts are spec'd very well. It's not bad. Price points weren't too bad. Let's pull up. Opening Mouser on my other screen. I did not set up my test board for 16 amps, I instead opted for the 8 amp 10 milliohm sense resistor. Which also gets you the higher resolution. That might help. Write word or read word protocols as summarized in blah 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 section. Let's see here. Single write. Slave address, acknowledge, write address, slave address. Oh, okay. So the read that I was using in the other one should work for this as well. Wait. Single read and write. Yes, it does. Multi-write, multi-read. Most significant bit, least significant bit. Charge option. 7-bit charge current rating. Charge voltage. Not using the on the go. Input voltage setting. I'm gonna want to check that one. Charger status. That'll be nice to know if the charger is actually connected. Input current limit. Yes, I'm gonna set that. Gonna have to set that. What are these charge options? Enable the iPad. Oh, nice. It's defaulting to the right power sense resistor. Yeah, all the ICs I've used for these battery boards chose them because they have at least half decent documentation, but also they were fairly decently priced. Oh, this is gonna be... I knew this was gonna happen. So unlike the other one where it's simply an address and whatnot, this one you have to read the individual bits. Oh, this is gonna be so much fun. Oh. Let's see if they have any sort of breakout board information. $200 and some odd. Oh my gosh. Let's see how this board communicates with a host. It's using jumpos. I can't remember what I did. Pretty sure I put the jumpos in place. I did. I have that jumper in. Not using that because I have batteries connected. Where's the other jumper? There's two of them. Can't remember if it's this one or if it's something else. I have that turned off. I don't need the internal thing. I think I have this one set to the factory setting. Doesn't help that I didn't match up my labeling to those. Oh, 6 fluke meters. Oh my goodness. EV2400 communication kit. Oh goodness. Connect J3 to the I2C. Oh my gosh! You want a I2C to UART connector? Oh my word! It better ship free at that price. Oh my word! And I thought spending $50 on this one was bad enough. Does it at least tell you what it's using? Because I'm wondering if the one I have here might suffice. Oh, no, it's gonna have firmware and it's gonna be checking everything. I know, right? This is why I built my own boards. I just used their references to have something to build off of it. But, like, I can't justify testing a part by buying a $300 breakout. Like, no. What if it didn't work? What if I didn't get all the functions I wanted out of it? Or I couldn't port it over to work in Arduino on the ESP32? Stuck with a $300 item? What? Absolutely ridiculous. USB connector. MOSFET. Switches, test points. Ah, here's the mixed signal microcontroller. Oh, of course it's a Texas Instruments part. It's a 16-bit microcontroller. Like, how much is it? $18. Like, oh my word. that price is so high because they want to recoup their R&D cost and their dev cost on software and everything, when in reality it just turns into a barrier of entry. Like, if you put this effort into stuff people could actually use, it'd be so much better. And instead, you're just expecting everyone to want to toss money at R&D constantly. At least with that other chip, it had a Windows program that at least pointed me in the right direction of everything to understand what values I'm supposed to be getting back. This one's going to be a lot more complicated. Lots of reading and comparing. But that will have to wait till stream 2. I haven't done much work with the RP lineup. The only thing I have is a screen for it. They do, but what I've found is a large portion of parts shortages, at least for me, are from the American companies, even though they're not producing in America, they're producing overseas. So TI is one of them, and there's one other. Now, originally the chip I was going to use for the battery management system was going to be a TI chip. At last moment, I can't remember, one of the suppliers I noticed had a not recommended for new design notice posted. And it wasn't even on their own website yet. It eventually showed up, but they were retiring it. But the replacement IC was not actually pin compatible. Which was annoying. Well, it's not just pin compatible, it's just battery compatible. So it went from being a 2 to 4S IC to being 3 to 5. And I don't really expect to go over 4S for any of my upcoming projects. And I know this project I need 2S. And part of the reason for having the board is because it can do sound balancing and whatnot. ESP32H2. Oh, Thread and Zigbee. Yeah, I never got into Thread or Zigbee, so Bluetooth 5 wouldn't be too bad. The big problem, though, is, at least when it drops, is you're going to be stuck programming in the IDF. Heck, they haven't even fully ported over everything for the S3, both in MicroPython and Arduino. They're catching up, but over a year after it's released, and not everything's available unless you're programming in the IDF. Which again, why do we need so many languages? Oh, I can program in Rust. Oh, I can program it in this. Oh, I can do this. Why? Just why? Oh, right. I did finally open up the pricing. So the BMS chip is $7. The charger chip that's on here is $5.23. Yeah. The FET that I showed you is $1.30. So Yeah. Yeah, so next task is just to get this working. So next stream we'll be getting this to work. Once it works, then I can start the so once this works, then I'll start the PCB designs, get a BOM together, order the parts, and then start 3D modeling the housing for the printer and the base station and the scanners. Get parts made for it, the first parts, printed for testing, and start assembling first versions, and then I can go through and refine these libraries so that the printouts are nicer and whatnot, so you're not guessing what this is. Yeah. Well, some streams have been long and I haven't fully gotten all the way through. I would still consider them productive because eventually it's worked out. Actually, interesting thing. So I'm gonna give a different software a try. Somebody on Twitter pointed this out to me. This works similar to the older, well, even current Autodesk Inventor type programs in the way how you model. So it'll be a little bit of an adjustment because it's been a while since I've used Inventor and whatnot. But it should be easier for me to learn than FreeCAD. And they have a few options. My plan is to use the base version to try. Where is it? It's $150. So can't argue with that. And it's a one-time thing. You pay it, you own it. You want the updates? I think apparently they do like typically 3 or 4 updates a year. If you want the updates, you pay another chunk of money. And I'm thinking this will be more than enough for my needs. And they have a trial program, so I'll probably do the trial first and use it. Yeah. But I think I'll enjoy this more than I will trying to learn FreeCAD. I've done minor stuff in FreeCAD, like changing colors and stuff like that. But doing full-on modifying of stuff in FreeCAD, it's driven me nuts every time I've tried. I already got KiCad loaded up with the S3, so I'll be ready to go for that when it comes time to designing. And most other parts I have, the only other part I'll have to do a test on is the battery mount, but everything else is set up ready to go. And yeah. Yeah. But it's nice. It's nice to see all the items kind of come together. Yeah, thanks for hanging out, Owen. And where's the end screen? End